Investigate vertical transformation. Describe the transformation, sketch the graph. Write domain and range. And we have two functions here. A is f of x equals to 1 minus half x squared, and b is f of x equals to minus 2 times square root of x plus 2. There are similar transformations, so I will do one of them and explain you the process. The other one is a practice problem for you. So let me take up this time square root function. So the square root function for us is f of x equals to minus 2 square root x plus 2. So let's start by describing the transformation. So when you are writing the transformation, it's a good idea to start from left to right. You will notice that if you start from left to right, you also take care of the order in which the transformation should be applied. So if you go left to right, all the products will be dealt with first and then the translations. So that's the beauty of this method. So for first thing which we see on the left side is negative here. This negative corresponds to what kind of transformation? It is reflection, and it is vertical reflection. That means the graph will flip vertically about x-axis. So the first one, minus 2, is vertical reflection on x-axis. Now, then we have square root x, which is a parent function, plus 2. This plus 2 is outside this parent function. So both 2's are outside. So they signify vertical transformation. So this is vertical translation 2 units up. So in this particular case, we have two transformations. Both are vertical. One is reflection about the x-axis. The other one is translation 2 units up. Now to draw this kind of a graph, what we can do is we can follow two methods. One is we can do it graphically. Second, we can find the points and then do it. So what I will do is I will adopt both the methods and show you. One method we will draw, the other method we will check, right? So let's first draw a square root x function. As you know, it starts with 0, 0, 1, 1. Then we have 4, 2. So 1, 2, 3, 4 and 4, 2. 5, 6, 7, 8, 9 and 3, right? So these are the key points for the square root function. As you all know, we can write them as, let's say 0, 0, and then we have 1, 1, 4, 2 and 9, 3, right? So these are the key points. Square root of 9 is 3, like that. So these points are enough to show the transformed function. Now, minus 2. Minus 2 means reflection on x-axis. So think like this is a mirror. So these points will get transformed and they will come here on from quadrant 1 to quadrant 4, right? So that is how you get minus 2. Okay, we didn't write about 2 itself. Is 2, I forgot, let me write now 2 here. 2 is vertical stretch by a factor of 2. Sorry for that. It is vertical stretch by factor of 2, right? So that I forgot to write. So vertical stretch by a factor of 2. So when we do this, we can do reflection and vertical stretch together actually. So reflection is minus, taking care of the minus. So we do reflection and then multiply by 2. So that could be the third stage, or we can straight away multiply by minus 2. So reflect, and then this is 1. 1 times 2 becomes minus 2. So it could be, well, let's do it in 2 steps. So the first step is reflection, which I am written here, so which I am doing now. And then I will multiply everything by 2. So this is minus 1. So minus 1 times 2 is minus 2. So this point comes here. 0 remains there at 0 itself, right? 0 times anything is 0. Now this is minus 2. Minus 2 times 2 is minus 4. And here we have 3 minus. Minus 3 times 2 is minus 6. So we get this point. So we get a graph which will be like this. Now we have square root x here. Then we reflect it, which is minus square root x. Then we multiply it by minus 2. So we have minus 2 square root x. And now the last step is to take them 2 steps up. So let's draw the last stage with another ink. So we'll take every point 2 steps up. So we're translating vertically by 2. So this point moves to 2, and this is already minus 2, so it comes at 0. And this one moves 2 steps, we get it here. And this one 1, 2, so we get it here, right? So with joining them, we get our final graph, which represents the transform function. So that is our final graph, and this is for minus 2 square root of x plus 2. So that is how we can sketch this kind of a function. Now I will show you with the help of points, did we really get the right points? Now as you can see here, how do points get transformed? So let's understand the points. Now let us say x and y are the coordinate points on square root x. Then what do you expect them to be on the given function fx? F of x is like minus 2 times the y value plus 2. So the y value is changing but not the x value. Do you see that? All the transformations which we have here, they are for vertical, right? It's vertical stretch by a factor of 2, vertical reflection on x-axis, and vertical translation. So the x points are maintained, right? So on the transformed function, which is minus 2 square root of x plus 2, x points will remain same as the original x points, but y points will change. How? They'll get multiplied by 2, so we get minus 2y, and then add 2 to them, plus 2. So that is the kind of transformation which we are seeing in our transformed function. So let's write down these points with this calculation. So x point remaining same, so we have 0. And what happens to this 0? When you multiply by minus 2, you get 0, plus 2 is 2. 1, 1. So 1 has to remain same. And this one, minus 2 plus 2 is 0. 4. So let's write 4 first here for x, and the y value is 2. 2 times minus 2 is minus 4. Minus 4 plus 2 is minus 2. And last point is 9. 9 is the x point which remains, and 3. 3 times minus 2 is minus 6. Minus 6 plus 2 is minus 4. So these are the points which should be on our final graph. Let's check. 0, 2. 0, 2. That's correct. 1, 0. 1, 0 is absolutely right. 4, minus 2. 4, minus 2. That's correct. 9, minus 4. 9 and 1, 2, 3, 4. So there you are. So that is using points, right? So what we have done is, we have followed steps to transform a function and get it on the graph. So you can sketch using graphical method, or you can calculate points. Either way you can get your results, right? So I will say adopt whichever is convenient to you, right? Now, so we have done this sketch of the graph, right? Domain and range. What do you think is the domain of this function? Domain didn't really change because there was no change in x value. So domain of this transform function remains same, and domain for us is x belongs to real numbers where x is greater than or equal to 0, right? Why did domain remain same? Since there was no transformation in x direction. Now range change, right? So y belongs to real numbers, but you can see y is less than or equal to 2. So that is the value, maximum value. So y is less than or equals to 2. So that is the range, right? So that is how we can answer these questions. I hope it's absolutely clear. And now you can follow a similar method to sketch a function f of x equals to 1 minus half x squared. So do both ways. Do step by step graphically and then check your answer with the image points. That ways you will learn more. That's the whole idea. Have a good look at it. Okay? Thank you.